Yes. Yes, 17 people. What screen is sharing? Get shared now? Yeah. Okay. Out of this, yeah, like I don't know. Like I'm starting with the problem I decided. So we will start with the back. Okay. Let me screen share all this page. And, yeah, okay. Give me a second. I wasn't prepared. Okay, we are starting with this problem. It's pretty easy, as you can see. Surely, like some easy problem. Yeah. So, like for beginning, I will just like read up the problem. So this ABCD is cyclic quadrature, and like we have some length condition, which is like no one cares. Uh, then like ing are in center of uh, ABC and ADC. So like from start, like you imagine, okay, they are like we suppose AC is a base, and B and D are like opposite side. So like now you get in centers, and now you have like circle with diameter meet like IB at X and JD at Y. And we have like if BIJD are cyclic, which is a very weird condition if you look at first. So this is given a cyclic, then we want to prove like these two are reflection of each other. So it looks pretty like interesting problem. Uh, Let me draw the diagram because otherwise, yeah. Uh, Cyclicity will be hold like just so. The first time we're going to use B-centric triangle. And I'm not sure. Okay. Okay, they said AB is greater than BC. Okay, I will just follow them. Though while I'm solving and uh,
Wait, sorry, the
AB.
triangle is getting like too bad. Can you just make the triangle like the old one and switch A and C? Like, what is this triangle? You cannot work with it.
No, 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 no.
Why? You cannot work
Uh,
with that triangle. Like, what is it? Yeah. Thank you.
so much demands, boy. So much demands. Uh, Wait, this is actually bad triangle. Shit. Uh,
Why don't you draw the circle first?
because like this. Uh,
Yes, there are two
see,
circles, but like,
wait. In circles.
what?
Wait, okay. So this is like I don't like the labeling, but like diagram looks nice, so we trust that.
Okay.
Uh, okay, wait. Let me just draw the diagram. So first you have I somewhere here, and then we have J. So it should be goes like something like this. There's a J, and now we have this BIJD is cyclic. Uh, Wait, you guys really want me to draw that? I will just draw. Okay, thanks. So skilled. Okay, this is like so good diagram. Trust me. Yeah. This is a cyclic and we already have like this is cyclic. And as you can see, the reason I draw that circle later because you can always modify your circle however you want. Uh, that's the liberty you have when you are hand drawing the when you draw like yes. Yeah. Now okay, I need to introduce. So first we introduce midpoint of AC obviously, which is M, because we have like circle with diameter AC, so M is the center. And now what happened is like there's this circle. Oh wow, such a beautiful circle. No, why you delete whole thing? Okay, it's still. Uh, Assume this is circle. This is one point, and where is it? Also wait, it does not has to lie on the circle. Obviously, that's like yeah. And I will label them X and Y in different color with lesser width. I need full volume just to hear. Wait, is there something wrong with my mic? Like, is it too low? I
No.
should ask. No, no? Okay, right.
Clear order.
Uh, yeah, okay, yes, thank you. Sure. So now everyone understands. So what we have is like this circle with the diameter AC, like circle center at M. So mx equal to my. We want to show x and y reflection about AC. So do you see like we have a center lie here and x and y are reflection about AC each other. So uh, which makes sense. So basically, like you want to either show like this angle equal to this angle, or like these are 90, or these angles are equal, something like that. Like something like this structure is following, because x and y lie on the diameter. Okay, and the given condition is this. Now, the point is like, what do you think? Like the reason this problem. Okay, I won't say anything, but like, what do you think about like this condition? Isn't this weird? How can you use this condition? What are some ideas? Okay, and also like I hope people talking about like problem, but I can't read whole chat. Uh,
Okay, it is cyclic. Maybe just start by extending some sites, like so as to exploit like PowerPoint or something.
We have
sure. Like we might like okay. I will just use black.
we have circles. Let's maybe try radical center. Like let's see where the circle with diameter AC and BIGD meet.
Okay, that's a good idea. So we have one circle with diameter AC, another circle of ABCD, and another circle of PICD. Okay. We apply radical axis AC, BD, and we don't know like what's exact point of intersection of these two circles. Yeah, but like that should pass through like this point. So it's like probably one good idea to like have this point in hand, and later on you will realize it's like crazy point. Let's call it H, uh, because that sounds good name. Okay, just ignore that point. That yeah,
Brother, just redraw it. It's not that hard.
nah, nah. Okay, so we have H, and now H should pass through if we call this like, okay, I will name it green now because, so if this point is here and this intersection is here, then that intersection should pass through H. Okay, that's the one idea. That's a good idea. But I want like you have like random cyclic quadrature and you have two insert centers and those incenters get in cyclic. So uh, because of radical axis. Uh, radical axis, yeah. Because this is like intersection of two circles. What can you use about cyclicity? Or like this condition is like too like kind of either like we have to explore like how this condition, and like one of the idea was extending side, but do you see what is this point supposed to be like? Call this something like XYZ. Okay, Z. Now like this Z point is intersection of two angle bisector, where you see two angle bisector. And now this is not in the same triangle, right? Like if it's in the same triangle, two angle bisector, we call it in center. But now it's like in diagonally opposite in quadrature. Like you have quadrature which is like this, and now you have intersection of angle bisector. What can you think about it?
I mean,
Something, yeah.
the lengths of the perpendiculars drop from Z to AB and BC are the same, and Z to CD and AD are the same. It would be nice if they were all the same. I don't know if that's true.
Exactly. Wait. I want to rephrase this as like if this condition is true, the quadrature becomes somewhat special, right? What are the special quadrature you know? Cyclic quadrature
We can try
and
it in like
Tangential or something.
incenter.
yes, tangential quadrature. The quadrature with incenter. And that's what I should also say, like this like quadrature which has in circle, which is like saying like basically angle bisector of all these three angles meet at four angle meet at one point, and then all of these lengths are equal. And this is like special kind of triangle quadratic, because like if you know sum of these two length is equal to no, yeah, sum of these two length is equal to this two length. But why that would like why that would be this, right? Like it's weird, and to prove this thing, like either we need an in center z to have like equal length, or like another thing is like we probably need a lengths to be equal, like some length change, but like we not like eh, doing length change here is hard. So what can you do? Also, how can you think about cyclic coordinate? What makes cyclic coordinate a cyclic coordinate? The sum of opposite angles are 180, right? So now, okay, so basically what I want to see is like there's some claim that this quadrature can have in circle, because we have in center and it's a cyclic. And can this be true? And so like it goes on
Wait,
assumption, and
is
if that, yeah,
isn't like there's some condition that if it's like if it is like both cyclic and tangential, then the diagonals are perpendicular or something.
yes, wait,
And like
our
IO
diagonal,
passes through intersection of diagonals.
IO passes through this diagonal is true. Our diagonal need to be perpendicular.
I think that is also
That
true.
is true.
Yeah,
Probably.
Like
I think that is true as well. Yeah.
yeah. Okay, yes, that's true. Wait, that makes this trouble. Okay, but yes, but to have this hypothesis, like there's one like okay, this might be false, but if it is true, how can we deal with it? Like, how can we either prove it or like use it here? I mean, like, is there a way to prove it?
wait, if that is true, then like BH perpendicular AC, so we know like B perfectly, and
Uh,
like okay, after that, in all honesty, you can just like put this on the complex plane and bash it out. It's not hard. Like
Wait,
actually,
like,
like
can
it's
you
not hard.
actually? Are you actually sure that diagonals are
Yeah, I
perpendicular?
need to check that. I will check.
How are you
Yeah,
bashing
because
it? How are you using the
no, like
condition?
no, he just like saying if it's has a bicentric quadrature, so it has incircle and circle, then like we claiming DH is perpendicular to AC, so D is become like reflection about the center, and now
It
we can back
is.
it up.
It was in like some unit. Like there was in some Otis unit.
Huh, interesting. But okay, let's come back to like this idea and put like there's no bashing happening obviously in this class. Don't even dream about it. And now, if we have has this in circle, right? Can like okay, not that. Yeah, okay. So we had this like suppose the quadrature with in circle and for it all conditions, okay? And we have this in circle I, in circle J, and these two meet at Z, which might be a yeah, which is the in center of quadrature. Now we have this is cyclic. So no, my I'm saying is like suppose a quadrature with like has in circle Z. Can we prove B I Z D is cyclic? If you like proving this diagram, then that imply like this has to be has in circle. And can you prove here? I mean, okay, you might feel like okay, we might need to use cyclicity, and yeah, true. But like, is there a way? Like, is there some good properties about I and J? You know,
Okay, I kind of joined late. Can you show the problem statement once?
but it was okay. This one, I sent the PDF. It's the second problem.
Second. Oh, are you actually doing 245?
Uh, Not really. I mean,
You
probably.
missed
I'm just.
opportunity, bro.
No, this is just okay. Um, Now here is a fact like if you have an in center, either you work with the angles, but now angles are a bit weird, right? Like we don't really know, like we know like this angle, like sure, like we can do some angle change. What can be this angle equal to? Call this angle C and this angle A. Then you can calculate this is like 90 plus C by half plus 90 minus A by half, right? And then we have this angle, which is like if you call this whole angle D, then like this is like d by half minus angle ADB, right? And what condition can make this like 180, like sum of these two angles? So like if we add these two angles, what we get, like it's like 180 plus c minus a by half plus I mean, okay, b by half minus, yeah, minus
Wait,
angle ADB.
how did you calculate angle BIJ?
BI, BIJ, so by like, this is angle B, okay, I should have explained that. BIA, and this is angle A, okay, my bad. It should be AIJ.
Yeah,
Okay, we don't know
exactly.
this angle. Yeah, we don't know.
Yeah, exactly.
Exactly, exactly. Uh, okay, I need to use that fact, right? Yeah, but it's a this angle. My bad. So it's so this plus this, and then like that is equal to 180, which is quite a thing. Plus angle AIG is equal to 180.
Isn't the angle AIJ being there not good sign?
Yes, it is not a good sign. Uh, Yes. So like, okay, I want like, okay, it's like come to me naturally, but like to force you guys to see it, I will just give one like kind of exercise, little trick. So like, see, we have AIBC is coordinated with in circle. We have I and J here. Do you guys feel something like how can you use I and J? Is there a good property about like in circle quadrature?
Can't you use like homotopy from B sending I to Z or something?
Can you like they are not collinear even? But
What
also
BIZ is not collinear?
BI, oh, Z, oh, I heard BIJ. Z, yeah, true. So let's like, on that idea, let's like, so, suppose like you draw in circle and this in circle, right? And like, then like this, so I can go to Z and Z can go to I. So like, yeah, you can use what you call Monjins to like, want to use that like this in circle external and just lie on BD. And like, then there's a homotopy, that's all. Something more.
Okay,
Also,
do this implies Ij perpendicular to AC?
why would it imply IG perpendicular to AC?
I mean, you can imply that when it is cyclic,
Radial
it
axis and
is palm fitted.
No. So like we have this condition, right? AB minus BC is equal to AD minus AC because it has in circle. Where have you seen this expression one more time in like triangle? Like suppose you have this triangle and like for now ABC and this is C and this is B like length. Then like where have you seen like something like B
But
minus C?
isn't this the tangential quad expression?
Yes. So like if you draw in circle, then this length is S minus B and this length is S minus C. So like subtraction between these two is also C minus B, right? So like yeah, towards like if you call this D, then BD minus DC is equal to C minus B, which is equal to BA minus AC, which is quite little nice thing to remember. And another thing to remember is like if you reflect this D dash, which is external X circle touch point, then AD bisect the perimeter of triangle because this become S minus C and this is S and S. So yeah, that's like 2 points you should always know. And on that note, if we had like suppose like this in circle touch at like something called D, no, not D, we already have D, T suppose, then we know like this length is equal to AT minus TC. But like again, like if this in circle touches at T dash, suppose, then we know this is equal to AT dash minus T dash C. But like AC is the same length. So you have like this both equation true. So this imply T is equal to T dash. Does everyone
How,
get it? How?
how did you get BA minus BC equal to DA minus DC as the first place?
We assume this quadrant has in circle.
Oh,
So
okay. Okay, I see,
yeah.
yes.
So like the the fact is like if this has an incircle, then like IT, which is like per in touch point of this incircle, is equal to like JT, which is in touch for point of this circle. So we get, as someone mentioned, IJ is perpendicular to AC, and like it has the same touch point T. And now you can do angle chase. Now the reason I call this Aij equal to like 90 minus A by half. And the point is like okay, it's like now you have to like just there's something called like believe, right? Like you have to just believe it, and that's become the part. Like see, either like there's two way to do this. Like we assume like this has an in circle, and if you assume this Bij is cyclic, then you can prove ABC is cyclic. And another way, which is like I will prove here, is that suppose this like two are like this is cyclic, then we can prove like what
For
IJ is
range,
perpendicular.
we use range for this,
If
right?
yes, we can use range also, which is
So then
another
it
way.
implies it has an answer.
Yes. The way actually Ronik mentioned, which is easier way to actually solve this problem without angle chase, is actually you extend this to meet here, called this B dash. You extend this to meet here, called this D dash. What do you know about B dash and D dash? Because IB is in center.
Midpoint of R.
The midpoints.
Yes. Yes. So that imply this is perpendicular to AC.
Yeah.
Yeah. But we also know B dash, D dash are cyclic. And we also know Bij, D are cyclic. Right? So Bij, D are cyclic and B dash, D dash are cyclic. So like, or like by angle chase or Zane's theorem, some people know that word. I don't know. I'm not big fan of that thing. Okay. D dash, B dash. And we know this is equal to angle IJB dash. And so we get like this angle. Basically, I will show a marker. This angle is equal to this angle, which is equal to this angle. And that imply IJ is parallel to B dash D dash. That imply IJ is perpendicular to AC. And like, okay, I'm like, okay. And like, if you call this in touch point T, which is basically the in touch point for J also, then by like this the thing we proved before, CT minus TA is equal to AC minus AB minus BA, which is also equal to BD minus DC minus DA. And this imply it has an incircle. So Z is an incircle. Does everyone get it what we did? So, and the
Yeah.
motivation was like because this cyclicity is there, the coordinate has to be something good. And if you try like okay, like I knew this fact before, like this T exists and it's perpendicular. So and the way I did it was like the angle change rather than this D dash and B dash because it's not like I mean it's sometimes motivable, sometimes you don't motivate, but the angle change is also doable. So now we had it as an incircle. So we know T is a touch point. What more we can have? Now like we now have to somehow introduce XY. Yes. Uh, someone
But
just said
as
something.
as they're saying, we have it as a we don't have it as so B.
Wait, is it possible that INJ are reflections then? That would be pretty. No, that's not possible.
Yeah.
Which are reflections?
That INJ, but like that would imply TI equal to TJ, which imply like in circle are same.
Circles are
Which is that true?
possible.
Actually, I feel it
Shouldn't
might be
imply.
true. But yeah. Uh, okay. Now, what can we have? We want to prove X and Y are reflection of each other. How can we proceed now?
I just had one question.
Okay.
Like how did we get angle D dash B dash equals angle IJ D dash?
So this angle is equal to this angle because given condition cyclicity, like
Oh,
D are cyclic.
yeah.
And then this angle is equal to this angle because ABCD is cyclic coded, and we assume D dash, these are intersection with circle. And then like we get this angle is equal to this angle. And that's why IJ is perpendicular to AC.
Got it. Thank you.
Yes. Uh, now it's okay. Yes.
If we prove xy parallel to ij, we are done. Or xy parallel to b dash c dash, we are done.
Yes, exactly. Because yeah, because these lanes are equal, so we basically want to prove XY is perpendicular to AC. How can
Then we do one more aim.
Yes, so now it's like backward tracking, right? Like we want to prove XY is perpendicular to AC, and that would like because we have IJ perpendicular to AC. If you do RAMs, like basically this angle should be equal to wait, what is this? Okay, I haven't draw XY yet, but that should be equal to this angle. And that's again, so we thinking BX, YD as cyclic. If you prove that that's a cyclic, then with the same angle change on RAMs, we prove like XY is parallel to YG. Do you guys see? Oh. And I will what? Okay.
I see that, but why it being like parallel finishes? Like we also have to prove the length condition, right?
Oh yes, so because M is the center and M lie on AC, MX is equal to MY. So this being perpendicular is basically mean like they are
Yeah,
like
okay,
equal
makes
length.
sense. Yes.
Yes.
What was the proof that ABCD is tangential?
So like we prove like IJ is perpendicular to AC, and now like because of that intertouch point of both in circles are same, and that implies these length conditions are same, and that imply it has a in circle.
Wait, IG perpendicular to AC came from the fact that this was tangential.
No. It came from the fact that this is cyclic. Just we never used like it's tangential.
Okay.
Yeah. That was like okay, it's a bit confusing, but that was just like how you motivate for it. Like that's how I think. Like I never get like direct to the results. Like I kind of okay, if this is true, then what results we can get, and there's some result matched the original problem. So bit confusing, but yeah. Uh, Now actually, wait. How can we prove those are actually collinear? Sorry, cyclic. So first of all, like uh if xy is or okay wait, whatever we want to like prove bxyd is cyclic, and what are the ways like because if that's a cyclic by range we get ij is perpendicular to ij is parallel to xy.
We might try to show like x such y collinear.
Why they should be?
I mean power of point, right? Then because it's like the radical center. If they're collinear, then you can just power of point. Like
Yes.
HB into HD, HC into HA, HX into HY.
Yeah, so you use PowerPoint like XYD and AC and ABC, right?
Yeah.
I think. Yeah, so like if this is cyclic, then this three circles and radical axis imply XY, BD, AC are concurrent. And yeah, so we want to show like in some sense they should be collinear. So if we prove these are collinear, then like we can use PowerPoint. Sorry, yeah, like hx into hy is ha into hc equal to hp into hd, and which implies the cycle. And is there a way to prove that?
Why again? Wait, would that be helpful? Yeah.
Okay, so like if we have x, y, h as collinear, uh, that like in like power, like the backward motivation for like if these are cyclic, then by radical axis they should be collinear. And like if we see like direct proof, then like hx into hy is equal to ha into hc because xy lie on the diameter, and this is equal to hb into hd. So this two imply this thing.
Got it. Thank you.
Yes. And now, yes. And now, like, question remains how we will do that. The last part.
Wait, we know that like that radical axis goes through this, right? So we should use that somehow. I don't know how.
Uh,
We can find angle CZA, right?
CZA. Yes, we can.
I think like Z and X are isogonal conjugates in ABC.
Yeah, I think that's true.
Wait, but why would you think that?
Uh,
Like, no, why did you think that? No, no.
No, like I was just angle chasing.
Okay.
so yeah, so the way it's happened is like you calculate angle CZA, and okay, I need to calculate. Okay, yes. So wait, it's not true. What's the most efficient way to calculate that angle?
It's just angle bisectors, no. TC bisects angle BCD and TA bisects angle BAD.
Yeah, okay, okay. So yeah, so like because like this will be C by half, like this whole angle half, and this will be whole angle half, and because sum of opposite side is 180, this will be 90. So angle CZA will be 90 plus B, and now you have like okay, that is fine. And now you have like if you consider like kind of 90, yeah. And it's like whenever you see this kind of thing, like okay, it's like it's bit motivation after come with practice, but like if you have some angle here, which is basically 90 plus A, and this angle is A, then like one way to like have this thing is like if you take like isogonal conjugate, then this angle has to be 90 because of angle chase, and because this lie on angle bisector, that has to be X.
Yeah.
Yes, but how we use that?
Wait, is it possible like HDY is similar to HXB or something?
Wait, now we are done.
HDY.
Similar to like HXB. That would be, I think, fairly simpler to show.
No? Now
Yeah.
we're done. We're done.
Wait, how you getting the result?
Like, we are finished now because angle XCA is equal to angle ZCB.
Oh, right.
And ACY is equal to ZCD. So they're equal.
Wait,
So
that just like doesn't need anything else there. Like that basically like that just need like we should have in circle and like everything like we don't need it except for authenticity.
No, I still don't get to finish.
Yeah, that's like actually it's like totally different from this group like other than first claim. So first like you have to note that X and Z are isogonal conjugate in triangle BCA. Then like so then like what you get is angle XAC is equal to angle ZAP, but ZAB Z is the in circle, so this is also angle ZAD, and by same logic we get Z and Y are isogonal conjugate in like D AC, and that's why this angle is equal to angle CAY. We get angle XAY equal to CAY, which imply like there is a yeah, and these angles are equal, so that's why we're done. Which is it is quite fascinating, I guess. And that's
But I think Mandar's
Can you explain the part how X and J are isogonal conjugate?
Yes. So okay, this was just the thing I told was motivation, obviously, and that's not proof. The proof is like okay, uh, like for now we will just consider angle bisector thing. So we have x here and we have z here, and as I proved, like this is 90 plus b by half, correct? B. So consider z dash is the isogonal conjugate, and z dash has to lie on angle bisector again. And then like if you calculate this angle alpha and this angle beta, then alpha plus beta is equal to 90 minus b. But then this angle is also alpha and this angle is also beta by isogonal conjugate. So we get angle call this CA. CBA is equal to angle B plus alpha plus beta by external angle theorem. And we know this angle is 90 minus angle B. So this implies this is angle 90. So this is 90. So isogonal conjugate of Z is some point Z dash lie on angle bisector such that C Z dash A is 90.
Yeah, got it.
But it's X. Yeah. Yeah, that's actually very great proof. I'm just like confused. Did I somewhat
Can you explain one more time why X and Z being isogonal conjugates finishes the proof?
yes. So we have they are isogonal conjugate. So that imply this angle. Oh wait, I will just color it. So what are the angles? Yeah, this angle, angle XAC is equal to this angle, angle ZA B because isogonal conjugate. But we know angle ZAB is equal to angle ZAD because Z is in center, so it's a angle bisector. And by same proof, we have like Z and Y are isogonal conjugate. So angle ZAD has to equal to angle ZAY. And this gives us the angle XAC is equal to XAC is equal to YAC. And so it's basically saying this, like we have some point A on this line, this angle is equal to this angle, and M is a center and MX is equal to MY. So because this is also equal lengths basically by like similarity or something, they are like reflection of each other in different cases,
Yeah, makes sense.
right? Yes, something like this. Yeah, and that's the finish. And that's the reason we need a in center Z because Z is angle bisector. Uh, yeah, it was bit difficult side if you say like isogonal conjugate. The my proof has like okay, this thing I need to recheck, but like what you do is like you assume x equal x z sh. I can't say hx intersect like this circle again at y, and by this like same radical axis you get like those are radical axes and those are parallel to should be parallel to IJ, and then you finish the proof.
Wait, what?
But
Can you repeat?
yeah,
Can you
this,
repeat the last word?
yeah, give me a second. Yes, okay, actually, like I'm forgotten something, but that does not finish us, surely, because we need like some more one condition, like yeah, that doesn't finish us. Sad. Okay, now I can't find the fix immediately. But yeah, this needs some more work, I guess, to prove BXT as cyclic immediately. But yeah, we have one proof of isogonal conjugate. Yeah, does everyone understand that isogonal thing and inside that? I think yeah, we will have only that proof.
Yeah.
My proof got some black magic. It's gone into it. Yeah, but okay. And yeah, so like, does everyone understand the feel of this problem? Like, so basically, the point was like this condition has to be something special. That's what you have to come up with, and then like by like some angle, like seeing the angle change and like uh, this angle being like 90 plus a, you have to consider angle isogonal. And this works without angle bisector. So like if z does not lie on angle bisector, then z dash should be some point here, and this angle will be 90. So like the point is like for this the angle bisector is 90, and yes, yeah, okay. Um, so everyone clear? Does anyone have doubt? So we can move on to the next problem. Uh, so there is a bit like we can take either this problem which I wanted to take, or we can take this problem which is quite a hard problem. Okay, we can take this.
Do three.
Oh, wait, someone had done three, right? Actually, wait, we will do three as a third problem. We will do this problem.
We should do 4 and 5. I feel.
No, actually, I'm changing my mind. So, like, okay, I will just reveal this source. Uh, so first, like, we beginning with like this China TST 2016 date 3, I guess, or P3. Yeah, so this was P3, and so we will move on to uh easier problem. This one is very good. Wait a sec. I have some evil plan in my mind. I won't say. How much time it has been? 50 minutes. Okay, we can cover. Yeah, yeah. It was so. Okay. Like in my opinion, I might be wrong, but like comparatively, China P2 geos are very harder than P3 geos, because I think like they just can't make a P3 level geo. Like they can't make that hard geo, but they can make some stupid algebra of like that hard. But yeah. Uh, I'm not going to do all. Like that's just not possible. Like I might extend this class for 2 hours or two and something more, but like all problems are not possible. Okay, let's do this problem. Uh, and it has a like other like once you understand it has quite a nice statement. So we have ABCD. Now we back to ABCD triangle. So it should be good problem. Trust me. Then we have this. Give me a second. Yeah, we have this. I can't draw a good circle. Looks so bad.
Like a lemon.
Yeah, yeah. All part of base by like my base wasn't a horizontal.
What is happening?
Try
Mine-
using shift for making the lines.
No, that's just cheating. We are truthful people. We do not have to cheat. Trust me, this is a circle.
What
Okay.
is this circle
And
supposed to be though? What is it supposed
tell me I was stupid.
You are violent.
So my bad. My bad. I misread. It just came from my mind. Like, wait, isn't like some condition just imply that it has that circle? But that circle just never existed, and I'm just like hallucinating. Yeah, I was. Okay, yeah. Oh my God, I'm sorry, guys. Forgive me. It was a different problem. Trust me. Uh, We have this length equal to this length. We have this length. But let me read it. Is that even true? D equal to B of C equal to CG. Then meet at X. Okay, where? No. Oh, so wait. This feel like okay. I won't talk. Some problem is there right now.
What is one, right? What is PT in the application like that?
Wait, guys. You guys are like wrong. See, there's an omega circle tangent to AC and B, AC at D and E. I was like, how can I be that stupid? Come on, man. Oh
Never
my god.
ask you to delete the circle.
Yeah. So true. Yeah.
That
No,
is
this is
better.
better.
That is
Yeah,
better.
this is better. It's all
That
part of plan. Okay, I just did it purposefully. I knew like the circle is perfect. Okay, is this ugly circle? This is not ugly circle. Okay, so I is here, and we have point L. Okay, let me explain the problem. Okay, my bad. We have omega, which is tangent to AC and AB and AD at D and E, tangent to sides. This length just supposed to say, we will get to that. We have F and G lie on BC such that BF is equal to BD and BG is equal to BE. And then BG and this thing, BFK, AP meet at K. This is point K. And L is a lie on minor arc of like BD on this omega such that this is parallel. Like this is parallel to BC. And then in center has to lie on XY. So they are asking these are collinear, which is quite weird. Is this weird? Like, there's no one feeling weirdness here.
Is
Should we
DF
introduce the
Yes.
Wait, what
So
is I
Saira,
and J? Can you
uh,
explain?
where are IJ?
There
कहाँ
is
पे है IJ?
I. There is
Oh,
I.
There's
oh,
a I.
okay.
I is the stand for in center. It's not like some, yeah. It's a good geo, guys. Trust me. The first one
DEGF
was
is
only
cyclic, no? DEGF is cyclic directly.
yes. I was just waiting for people to realize.
Yeah, so
Yeah.
Yes. So So point happen is like these are reflection. So if you see like the way you see is like in center BI, like that's like one great way to see. That's why I'm
I
saying
is center, yeah,
like
I is center. That's all.
yeah. So like BI is angle bisector that imply like BA map to BC in like reflection over angle bisector. We have like BD equal to BF, so that imply like D is a reflection of F. D is F is
ID
a reflection
equals
of
I.
D about BI. Yeah, so it's a perpendicular, and that imply like this length is also equal to
ID
this length,
equals IF, ID equals IG, but also ID equals.
and this length equal to this length. So this because like this equality
Wait,
length condition of
how did you
outside.
get after ID equals IF? How did you get I like
So
the other
ID
thing?
is equal to IF, and
Yeah.
ID is equal to IJ because
How did you
it's
get that?
a tangent to it's a tangent to BC and AC, right? So that imply like
Yeah.
the wait, am I okay? This angle is equal to this angle.
Uh,
Yes, and because it's a tangent,
in
AD is equal to A. Like
wait,
this is
why is that angle equal to? Okay, yeah, fine.
why
I
came
mean
the other
Bisector.
Shouldn't you
no,
join
not
with
not
I,
A,
BI, and
not
CI?
not K, not K, obviously. Okay, wait, that angle. Wait, what? K and DI. But okay, let me explain this part. This is A by half. This is A by half,
Okay,
and
now
the AD is
congruence. Okay, fine.
yeah,
Yeah,
AD is equal to A. That imply like
yeah,
yeah, my bad.
okay.
ID equal to IF, and this is equal to IJ. So that imply like as Nishan mentioned, DFEJ is cyclic with I as a center. Okay, so let me remove the kind of unnecessary part. So we have like I as a center, which
Wait,
is
create
nice.
DE intersection BC and DF intersection EG or something.
Yes. Uh, Let me like just try to say why we can motivate for that. Wait, let's just come here because yeah. So now the thing we have is like we have this
Wait,
another
can you
circle,
tell
right?
me what K is? K is DG cap FE and I is Wait, what?
I is the in center.
Okay.
I is the in center and K is a DG cap FE. Yes.
Okay, got it.
Yeah. So now like see I is the circle of this red circle, okay, which
Wait,
passes
so
through
then
this.
how is dk equals fk?
Oh, not K. Come on.
Oh, okay. Okay, like di
Yeah.
equals fi trivially, but dk is not
Yeah,
equal.
yeah, yeah, yeah. It's just some mistakes happens. Just yeah, this is perpendicular to this thing. Forget about this lens. Because of basically yeah, this thing imply I is the center. Why is I equal to ID? Because like AD equal to AF and I lie on angle bisector. So like by congruence triangles, ID equal to I. Okay. Now the reason why like this one thing is motivable is like we have the intersection of diagonal and the circle is cyclic and we have line passing through intersection of diagonal and center. And to like visualize it in a better way, we have something like this, and this diagram is needed. I am not trying it for like just to explain. Uh, we have this circle and I is the center, and we have something like DG and AP, and then we have to work with IK, and like now here comes a mercurial thing, right? Like because I is the center and K is this intersection of diagonal, we know this intersection intersected perpendicular, and this is a mercurial point. Yes. Uh, yeah, that's what we learn like last geo class, I hope. So I will draw this. It should not pass through. I mean, it may not. I'm just bad at drawing. Name it something X, and yeah, mixed. T. Let's name Mikkel point T. Why it's intersecting there? It should not. Or does it?
You are giving us a hint?
I'm myself discovering it by. uh, Is it necessary to intersect there? Actually, it is. My diagram was too good that like, just like I can't help.
No, I
Yeah,
don't think that's necessary.
yeah. It's not necessary. Yeah, guys, I'm lying. Trust me. They call this XY and call this Z. We don't have L is a collinear, but okay. Let me just summarize what happened. Like we introduced X and Y as the intersection of like D cap G up and FG and D up cap EG, and we have Y, Z is a mercurial point, then I, K, Z are collinear. This is been known by Brocard's. Not Brocard's, like, I mean, sure, Brocard's. And now we want to show Li on it. Everyone on the same page, right? No one confused. Like this part. It's not like obvious to get, but yeah.
Isn't it suffers
And
for the DFG cyclic?
yes, so because like we prove ID equal to IF equal to IG equal to IJ. So I is the center and like all of this lie on this circle center I.
Okay,
That's
okay.
why it's cyclic. Yes. Yeah, they're like crazy that we ever use like cyclicity by having center, not angle chase.
Yeah.
Yeah. So now any ideas? How can we prove L? L is weird point. L is weird point.
Can we look for another circle so we can try
Radical axis?
yeah.
Sure. So you
Can
guys
we use
like
the
not
homotopy?
using homotopy?
Sending like I to like in circle to like omega. Like we know Z is
Yeah.
center of like omega or what is the center of omega? I don't know.
Let's call it O. Okay. Yeah. So it's whatever here.
And like
And then
if
OD and yeah.
we draw in circle as well, we know A, L and the diametrically opposite point of the touch point are collinear by homotopy.
Oh, interesting. Wait, let's check it. This is a good language. There's one idea. Yeah. I actually don't know the solution on that nice, but that's the idea. So like if we have this in circle, which is quite look like in circle with I as the center, and like that this in circle get mapped to like omega because like both are tangent such thing. And now like this is L is mapped from this thing. Call this like T and T dash. Then like ATLR should be collinear by definition of L. But we don't know, like then AT intersect here at external X circle tangency. I'm not sure how we're going to use that. There's a, yeah, Z is inverse of K in the Z circle. That's true. By Brocard's. Um, yes, by angle bisector, BD equal to BF. I'm again saying by angle bisector BD equal to BF. And you guys haven't used something yet. Something which I like hinted you long time ago. Okay. Okay. This is like okay. I should have just explained my thought. Yes. Does anyone have idea?
Wait, is there any subclaim we are trying to prove right now, or trying to find other
No.
subclaim?
We just like trying to find any good thing about diagram. We don't. I haven't given anything out.
So if we prove that LK is perpendicular to XY, then we're done.
LK. Yes, that's the one way to think about it. If we prove LK perpendicular to XY, but we still haven't know like how to relate L with like K, right? Because like it's still weird. Like F and G are not like related to omega. Yes. Also, there's like how I thought of this problem, right? So like first like this diagonal thing, then like the idea comes like these two lengths are equal, which like basically mean like length equals from B, which imply like it has to reflection about BI. So that's why like I get ID equal to IF, and similarly then like I equal to IG, and ID equal to I is like just like this is the first thing you come up with. So I get this circle. So I had this circle, I had this circle, and then like because this intersection of diagonal, I thought of Mercurial thing like this is perpendicular to this, and as someone mentioned, we just want to show LZ is perpendicular to XY. But now I'm stuck. Like I'm not like. Do you guys have any other idea? Any other intersection circle?
LO intersection BC. LO intersection BC.
Oh damn.
Wait, what have we done till now?
That
How
makes
is
it perpendicular.
point defined, by the way?
Center of omega.
I see.
Call this H. Okay. So wait a second. That does not necessarily perpendicular, is it?
It does parallel to BC. It does necessitate perpendicular. The tangent through L is parallel to
Yes,
BC.
yes.
So
Yeah. So by definition of L, which is like parallel to BC, that's perpendicular. Now what can we do? Also, this is like kind of good because like wait, is it? Yeah. So like call it H, and we also know like OD is perpendicular to AB because by definition, is it the omega is tangent to AB. So we get like BDOH is cyclic. Well, it's kind of looks like we are going out track, but yeah, this is like cyclicity we have. Is there a way to, but yes, tell me this work. This so much efforts just for this. Yeah. I'm just like, whenever you're stuck, there are like few things you should try always. Like obvious thing, which is like major part, like which will really give you solution, is look for new point you can introduce, right? And like it's like sometimes you will introduce bad points like which are not useful at all. But like sometimes you will like you never know they're useful or not. There are many solutions which are like weird, like you just never thought I should work on that. One of them is like cycle of healing H. Okay, but I still draw it because like there's one way you can use it. And another thing is like you should look for like some few things. First is like angle chase, like all the angles, like however many angles you can get, you should get them in your hand. Second, radical access power of point. Whatever circles you have, introduce some more cyclicity, basically cyclicity. And third, projection, like project some like some length, like whatever cross ratios there or harmonic cross ratios. Okay, now let's just start from the basics. Have you guys angle chase everything here? Like, do you know this angle? Do we know this angle, or is it like possible to get it without like weird efforts?
Yeah.
That is
Wait,
90
how?
It's
minus
90,
Minus.
90,
Oh, yes,
90.
yes, because this angles and this angle is 90 minus b by half. So that angle is 90 minus b by half. Similarly, you can know this angle too, which is 90 minus c by half. So I will color it double. Do you guys see something now?
Angle DYE is 90 minus A by 2.
Oh yeah, so
This
y lies on the circle.
is 90 minus a by half. Wait, yes, wait, who said 90 is stupid? What was that?
Yeah, Ron
Uh,
said it, I think.
Yeah, y lies on the
okay,
circle.
okay, Nisha.
What?
This is 90 minus a by half. But like, wait, do you guys have a reason why it's lie on omega? Like you have to prove like that angle.
Yeah, like
Angle
angle DO, like
90 minus K. So that
Yes. So from here, now we use this type. That's why there was I. Uh, we have angle, whatever is this? DBH is equal to angle DOH, and angle DBH ECH is equal to angle EOH, and this both add up to what? Angle
wait,
180 minus A.
better. Like ADOE is cyclic.
Oh, yes, yes. Yeah, that's why you get distracted. Yeah, this is cyclic because OD and OE are tangent, and this is angle A, so this is angle
Or
180
like
minus A.
DEY is, or DEY is similar to like in touch triangles. So
I agree.
How
Wait,
did you get
DY
the
similar
angle FD is 90 minus T by 2 for that angle?
FDE. Yeah, so because like DF GE cyclic, like, and this angle should be equal to this angle, but we know DB is equal to BD is equal to
Ah,
DF.
I see. Yeah. Yeah.
Yeah, and that's why I mentioned some time ago, like I mentioned it again that DB is equal to DF because no one tried to angle chase this. And that's like first thing, I mean, not first thing, but like angle chase, basically, guys. You should angle chase. Uh,
How
one
do
should
you know
angle chase.
which angles to chase? Like there are a lot of angles, right?
Yes, yes. That's why I just went like I actually like the way I angle chase was like this is 90 minus b by half and this is 90 minus c by half, and I never cared about these angles. Like even though they're like trivially to see, but I never cared because it's hard to visualize those angles randomly in head. But when you have a diagram, I just randomly spawn like, okay, do we know this angle? And then people just find it, which is 90 minus b by half. And then by symmetry, we know this angle too. And then we get. But and another way was like, don't you like look like this should lie on omega? Like, wasn't that like first intuition? I mean, that's like I accidentally draw it on omega, which is like quite funny. So we have DO. Okay, that's fine.
Try
There's
to
some.
find out all the angles which are possible to find out and then check which one gives you the most useful result.
Yes,
Okay.
it's hard. I agree, it's hard, but well, that gives us some most beautiful proofs in some sense. Like now we have this angle is 180 minus a, so there this angle dy is half of that. And yeah, that's what I said. Like just try to find some angles, whichever are possible. Sometimes you can't find angles. Sometimes they are ugly. Like I wouldn't like. It's just look that like this problem is good. Uh, yes. So we have like I don't know like what these resonance like whole diagram become. But why rely on omega? Now what?
So we have A T prime and right.
Uh,
By
can you
homotity,
repeat?
A T prime L.
Yes, yes. But assume it's a line.
Is ALOZ cyclic magically?
Wait, what is T prime?
Uh, the diametrically opposite point of in touch point T of in circle. So basically, like in this here, we have like this is a circle, right? And there's some L which is parallel to BC. Then we consider in circle. And by like if you take a homotity in circle sending to omega, then that L should goes to another point which is like also you parallel to BC when tangent. And
So
it
this
becomes T
implies
dash.
that Ly is the diameter, because by the same homotherty T dash I, we know I goes to O, T dash goes to L, so T must go to the diametrically opposite point, which is through Y.
Yes, actually.
Homotherty
So
about
LOY.
Yes.
Wait, then
Yeah.
yeah, LOY.
Okay. Let me see, explain how people got that. Consider this green diagram. So we have BC and we had these points. Okay, this is like too much font and the color is very bad, but okay. Anyway, we have E and D here. Now, like the point is like L is a such point which is like tangent parallel to BC. Then in homotherty, where this omega maps to in circle, it should map to some T dash, which tangent is also parallel to BC. But you see, like tangent from T is BC itself. So if you take like diameter opposite point T dash, then like I is there. So like the tangents are parallel, and that's why it's also parallel to BC. And because there's a homotherty from A T dash L is collinear, are collinear. Now, the best thing someone, Nishan noticed, I think, was like this triangle DYE is similar to in-touch triangle because the angle of DYEs are 90 minus A by half, 90 minus B by half, 90 minus C by half. So, this like, because like this tangency also follow, these two are actually like similar. Okay. Forget my name, cliche. I don't have nice point, but yeah. So if BUT are in touch triangle, then we actually like have this thing because of the angles. Because these angles are 90 minus a by half, 90 minus b by half. And that's a good thing to remember where you have 90 minus a by half. You many ways you're going to use that. Another triangle which has this 90 minus a by half and so on are the middle triangle, like not middle triangle, but like if you consider this triangle, midpoint of arc, midpoint of arc, midpoint of arc, these are also like similar. They are actually homothertic to in touch triangle too. That's just another fun fact. Okay, so we heard those are like uh, similar, but we also know like UV is parallel to D, and you already have this is like on omega, and this is like call it this is also omega, but capital omega. No, okay, this is gamma. No, this is not gamma. What is gamma? This is tau. Okay, call encircle tau. Then like this tau is homothetic to omega, and because U is parallel to D, we get like these two triangles are homothetic from A. So this triangle gets sent to this triangle, and now so T should get sent to Y. So T goes to Y, and because TT dash is a diameter, LY is diameter because like TT dash is parallel to also like parallel to LY, and LY is a diameter now.
So we just need to show that Z lies on the circle, right?
Yes.
Because LZY is 90.
Yes.
Show
So
the
now like we have like ly is the diameter, o lie on this line, and now because this is a 90,
and that's
so wait. Uh,
and by Mikhail, right? Since Mikhail Z should
Yeah.
lie on DEY. So we're done.
Wait, z should lie on dy, but we still need to prove like li z are collinear. Like we basically have something like this. Like there's a z, and you have like ik here. Okay, okay, yeah, it's this term.
No, like Z is intersection of IK with XY. We know that is 90. If
Yeah,
we
yeah,
want to
yeah.
show that
I get.
LZY is 90, it needs to lie on the circle, and we know that lies on the circle because it's the diameter.
Yes. So yeah, as we prove like this, omega is basically circle with diameter ly, and we know angle LZY is 90. Z lie on omega. So this circle was indeed like before it was precise, but I just draw. Yeah. So Z should lie on here, and then that imply like we know like ik is as ik is perpendicular to xy, and like lk is also sorry, yeah, lz is perpendicular to xy. This imply like ik z are collinear, and we are done. Does everyone understand? And does anyone have doubt? Also, well, like this is the way this is like actually very.
Z lies on the circle.
Yes. What?
Does this mean that Z lies on the circle?
Yes, Z lie on omega.
Okay.
Yeah, it does not look like that, but yeah, it's also like you should also get in that also. Like sometimes figure just does not look like Z lie on this, and it might do. Well, I have like actually one great story to tell about that. This because of geo, what things can happen, like bad diagrams. But let me explain my actually way to actually get ly is the diameter. The way I did it was like you calculate this angle. Don't ask me how. Like, wait. Yes, you can calculate this angle. Give me a second. Okay, it's a bit hardcore. This is 90 minus this. I'm forgetting my maths. But basically, what I did was like I calculate angle FDL, which comes out to be 90, and like that imply ly is a diameter, and you can calculate angle FDL. It's just okay. Yeah, you have this angle O. This angle is B. This angle is also B now, right? And because O is a center, uh, O is a center of like omega, so that implies this is B by half. Angle LED is B by half, and we know this angle is 90 minus B by half, right? So that implies this is 90. Where like this is equal to angle LEG. Both of them are 90, and that imply like ly is a circle with that. So we didn't need that homotheity. Like, but the homotheity was great idea actually. I love that idea. But if you just ignore that and just like believe on angle chase, it was just angle chase. The whole problem was angle chase and Procard. Yes. Okay. Does everyone understand?
You know,
Does everyone understand
the problem
angle?
finishes when we realize that L1 is the diameter.
Wait. Oh. What?
Can you explain the end of the problem when we realize that Ly is the diameter?
Yes. So Ly is the diameter, and by Brocard we know Lzy is equal to 90. That implies Z lie on omega, right?
Yes.
And so now we have like see like this is this line xy, and we have like this z point which lie on omega, and za is perpendicular. But we also know like when like some point I and k are there, such that ik is also perpendicular to xy at z, right? So those two lines are same. So like ik l are just collinear. Did you
How
understand?
do you know that L How do you know
Or
if L
better way to phrase it, is like, suppose we have Z, right? We prove like Z lie on this thing, and we have I and we have K. We know these are perpendicular by Brocard. Now you just extend this to meet omega at L dash. Then because this is 90, this has to be diameter. But we know like Ly is a diameter. So that implies L dash equal to L. Do you understand? I think you had some different doctors.
One
yeah.
question. Can you
Yes.
can you show just quickly that once y is angle LED is equal to b by 2 omega?
LED, yes. So angle LED is half of angle LO. What am I writing? Right. LOD, right? Because O is the center, and because of the cyclicity, 90-90 thing, we never use here LYO or collinear. Yeah, because 90 this equal to angle B. Yeah, and that's the way I did it. Like I just changed the angles and yeah.
But
So, yeah, homotheity is I think homotheity is better, but like yeah, it's hard to come up with. Like I didn't believe homotheity would work actually, so it's good to come up with it. But yeah, so does anyone have a doubt or like some? How do you motivate that? How do you come up with that point or something? I hope I explain mostly how I come up with everything and angles.
Wait, why would you think of
Uh,
angle change over homotheity? What?
because like that's what I do, right? I do first angle change and then I like look for life. Like it's like obvious, like this angle is B, right? Like because of this cyclicity. So I like it's I just happen to know this is B by half. And because I happen to know it's B by half, I happen to know this is 90. And because of that, I happen to know Ly is the diameter. The whole problem was just falling in the same.
Wait, so you just happen to know the solution or something?
I, the brocard was, I think, the main point. Like brocard is kind of hard to come up with, and that's why I took this question. Like, whenever you see something like quadrate, try to complete that quadrate. Always have a complete quadrate in hand. So x and y and make your point. Okay.
Just one
Okay. Fine.
question.
Yes.
Like,
Yeah.
I'm so sorry, but why would like the point where IK intersect like XY, like we know it's perpendicular, but why would that point have to lie on omega? Like,
We prove Ly is the diameter, right? You understand that?
yeah.
And Z is perpendicular. Like, give me a second.
Z is Mikkel, D is ZY, Z is Mikkel.
Yeah, Z is Mikhail. So like,
D is ZY, D is ZY cyclic.
T is oh, okay, okay, wait. Yeah, I understand.
That's
Yeah, I
what
was
Romit
also
said. That's
confused.
what Romit said.
Okay, okay. So see, because Z is a Mikhail point of quadrate DFG, Z has to lie on like DYE, and like because DYE has a L as a diameter, like diameter opposite point, we get like L has to be other point. Like this is the reason Z lie on omega. Yeah, I'm like actually very sorry. This is actually not the reason L lie on omega. The Z lie on omega. The real reason is Mikhail point. Yeah. Oh, I should have realized that long time ago. Yes. So Z lie on omega because like Z is a Mikhail point. So the definition of Mikhail point has like it's lie on omega f z y no, it's a d f x and x e z. Because now your doubt is clear. And are you sure, right? So wait, so you get like now Z lie on omega, right? And now the point is like so Z I K are collinear with like angle Y Z I is 90. But we also have like because L is a diameter opposite point, angle YZL has to be 90. So like these two, like this I and like again like L, both of these are 90 to this thing. So they have to be collinear. So ZIK. L colon. Okay.
Yeah, makes sense.
Yes. Yes. And yeah, that's nice catch. Okay. Yeah, this was the problem, and it's quite a beautiful problem. Does anyone want to guess the source? Uh, we'll just check out.
I think it was already revealed.
Wait. When it was revealed, who revealed it? No.
Is this a team selection test problem from any country?
Yes.
Is this a Chinese TST?
Yes. Again.
Of course.
Also, go more. Go more. It's
Is this
like
from
now.
20? Is this like from day 3?
2018 or something.
Yeah, 2018 day one P3 again.
What is your obsession with China TSTs?
Oh, and
He's
also
jobless.
like
He's jobless.
you're
That's all.
missing you're missing
He's
one
jobless.
point.
He's jobless, guys. That's
You're
all.
missing one point, brother. Like P3, China TST P3 is my
No,
obsession.
I think you're missing 3 words: China TST 2018 and D1.
Okay, and yeah, I don't know what day was this, but yeah, 16th. And is there some match? So there's something more we can do is get a high trick. There's another China TST hidden in this summit, as you can see. Uh, do you guys want to guess what does look like a China TST? Now it should be obvious, I guess.
4.
Yes, what is China TST?
Then
Also,
let's
the
do
way
that.
it's written on the thread, it looks even terrible. Like they just literally write like this late line in one line, this late line in another line, and then there's another this late line in this and this like they're like some random 4 lines distributed. Uh,
Brilliant.
okay, I'm not sure. Do I want to cover this road? It's like these are no near to P3 level. This is actual P3 problem. We can do it, but it will take like surely 1 hour at least. Or we can just do this problem, which we can cover in half an hour. Sure.
Will you be sending the solutions to the problems?
There's no need, like just try them out and solve
At
them.
least the sources.
Yeah, okay, sure. Okay, no, I will just tell like this page. I don't know why I had this page. Like I thought like I will be covering this problem, but it's like too much to even cover. Also, like
Okay, could you do like
okay,
problem number 7?
I don't remember the solution. Do you guys want to figure out?
Why don't you just come up with it right now so we get an actual view of how you think?
Fair, fair.
Ah, you guys are so bad. Okay,
Oh, we
sure.
have to do it. We
Wait,
they are
Yeah,
not
yeah,
giving an
he'll
option.
just like remember
But
the solution
1.7
halfway through.
feels kind of like a length bash.
Which problem are we talking?
It's
Oh,
it's feel like a lane bash, but it's actually a very beautiful problem. Like the reason I added here because like it's atmosphere. And I want to say one thing, like I like all geos, but like there are like only few like gems which are like count as my favorite geos. None of these problems are right now in my favorite geo problem. Not even this, but this problem is my favorite, one of the favorite.
Is this
And
from
I
some
think
Chinese TST?
no, it's not from Chinese state. It's not from any like well-known contest. Like I don't think you guys even know the source. It's like like some geo like mains or geo lovers just make a mock or like contest, geo contest. It's
Wait, is it
from
LIOG?
Yamaguchi. It's not LIOG. It's not from LIOG. Uh, the
it's not the
proposer's
Anand Google
name.
one, right?
No, it's not even Anand. By how many you know Geo King?
Oh,
Four.
Yes, yeah.
okay.
Who?
Fine.
Who?
Geoking, Geoking.
Geo King.
One more jobless home. Okay.
But it's okay, bhai. You call him jobless. Like he was the reason I got into geometry. Let's just say that. Yeah. Okay. Let's do this problem. What does it say? Center at x, y, z. Let's quickly. So each line. Okay, the next statement just doesn't make sense to me. But okay, let's be brave and courageful and try to draw a diagram. So we have ABCD and
Draw the circles. Don't draw the diagram. Don't draw the diagram.
fine. Okay. Uh,
I'm
so
trying to be.
basic yeah. So basically what it's saying is like so omega 1, omega 2, omega like all this omega cut like equal amount for like BC and like okay wait I realized like
Wait, so
this
each each of them is 4 equal, or like all those 12 equal are equal.
yeah I don't remember but I think like each of them are equal.
Okay.
That's why I say I shouldn't just read this. But okay. So, okay, now we have to brave and actually try to draw a diagram. It's quite fascinating. So first, like let's draw some simpler diagram.
Yeah, like it's
So
going to be.
wait, what? Oh yes.
So there's just saying it seems like it's going to be looking roughly like incentives and acceptors.
Actually, yes. Yeah,
It's
like
more like the 9-point circle being inner one.
yeah, but like 9 point circle does not satisfy the property, but yes. Wait, I hope that's what this problem seems, right? Like each line is cut off equal 4 parts. Yeah, yeah, yes, yeah. This is another circle. And no, like I like yes, like that's like one way to I trying to visualize. Like even I don't remember. I told you right. Like I don't remember anything right now. I'm reading them. So I feel this is like the best way we have 4 circle ever in our life.
Last circle, if you want to call it a circle, I mean.
Please, like this is the best. Wait. How many of you guys not liking these circles? I am the just big fan
I
of
think
my
they're
diagram.
fine. They're like fine.
Yes, yes, exactly.
I mean, you
Ronnie
did
just
try. You
complained.
tried. You tried, bro.
Yes, thank you so
I
much.
draw better
It's better
circle.
than what you do usually. I'll give you that.
You can take it. Okay, so if equal chords, so if like the radius are same, then like the circumcircle in the ratio of the radius, and the radius in the ratio of the angles. Is there some power point? Wait, the midpoint thingy. If you have a midpoint, does midpoint actually helps? I can't. Yeah. Uh, so we have this sum equals sum minus this sum. Looks ugly. So
Okay, could we
yeah, I
like
just
think about some inversion because there are just too many circles here.
That would just make it worse.
I mean the inversion will have a center, but equal chords can't be preserved everywhere, right? So I'm just figuring out is midpoint of like is side length of BC somehow like related to them, and I'm feeling it does not, but still the hopes are never lost. We have this perpendicular, this perpendicular,
You
this
perhaps
perpendicular.
know that it's the opposite with YT said.
Wait,
How do
it's
you use the equal chords, like without bashing? How do you use that anyhow in
wait,
synth theory?
wait. How do you use equal chords? Yeah, yeah. I'm just thinking. Also, Bhairav, do you got something like I think you got something. I just said I'm not sure. Do I want to know
Wait, can
that?
you draw midpoint of XY? Like X looks like orthocenter of YTZ.
It's actually true in like eccentric things, right? Yeah. Also, wait. I just realized if you call this the eccentric like or like X circles and in circles, we can use those properties to emit here.
Let us
Actually.
MMP. Let us MMP.
Ah, those words are not known to the universe. Oh, so wait, let me just read. Centroids. What is the radical axis of omega to omega 3 omega?
Center,
What?
radical center. What?
How good does it? Okay, so like if G is here and then like some radical center R1, then ratio G divides into X and radical center 2 to 1. Okay, this is 2 is raised to 1. And I came to problem because I want to backtrack actually. Like, so see. If you
Wait, so
take a homothety from G, then it will go to like radical centers, right? And do we know something good about radical centers, like of 4 circles? Also, yeah, Riyansh, what was your thing?
if you take midpoint of XY and you draw its foot from and you draw its foot onto AB,
PCI. Oh, God. Yes.
then that foot will lie on the radical axis of this omega 1 and omega 2.
Okay, could you like
Why?
join ZT, TY, and YZ? I think like it looks like ABC might be the 9 point circle of ZTY.
Yeah, exactly.
Oh, wait, by the way, Riyash, why is that your claim? Also, it's like the same thing to say for this perpendicular, so that's symmetric actually. But yeah.
Yeah, it is
Uh,
symmetric.
wait, why are you claiming that? That's
Like,
actually,
like could you draw it with just 2 circles and 1 line? Okay, fine, you can zoom in, I guess that works.
yeah. So
So like, it is just symmetry, no?
that's a great idea. Okay, and that has okay. Let me get a nomenclature. PQR. Okay. I mean get. Okay, guys. So let me have this Riyash idea, which quite fascinating for me. So we have P and P is a midpoint of XY, and because like we have these perpendiculars, right? Call this X dash and Y dash. Then note that like because of like P is a midpoint and you're drawing perpendicular from P to BC, call it Q. Then Q is a midpoint of X dash Y dash. Okay. And now if you try to get a power of point, right? Qy dash into qy2. This equal to what? Qx dash, and this has to equal to qx1. The reason is because like this length is like, yeah, this xy y1 y2 is equal to x1 x2. So this imply like y dash y2 is equal to x dash x1. So this length is equal to this length, and this length is equal to this length. Do you guys see? Does everyone understand? So like because Q is the midpoint of this midpoints of the chords, and then like these are like chords is segmented in equal length. The Q become a radical like point of like same power, and
Yeah,
this
exactly.
and this everything
In
is true
particular,
for all sides. So
yeah, exactly.
this
So
also
those
has
3 points are collinear,
these 3 points are collinear
which
exactly
means
because
P lies on circle ABC.
exactly. So, so these 3 points are collinear because like all of them have equal power with respect to x and y, like x circle and y circle, and it's a radical axis. Radical axis is a line, and what we have in another diagram is like these are points such that this, and these are collinear. What a beautiful diagram I have. This and these are collinear, and
So,
when that imply p lie on a circumcircle,
so
which
the
is
6
beautiful.
midpoints are all concyclic.
Yes.
Right,
Yes.
ABC.
Yes, and now it's my time to draw ABC.
Which probably means that they are an autocentric system and ABC is the 9.7.
Exactly. X is the XYZT is an orthocentric system and ABC is the 9 point circle.
Um,
It is very cute.
yeah, indeed. Let me just actually I need to think why it's obvious. It does not need to be obvious. I don't understand.
Oh
Let's
wait, if
figure
that
out.
force like doesn't that force XYZT to be like Incenter, incenter plus like excenter.
It does not actually. Like there are like other configuration other than incenter excenter which has this thing. So also wait, do you guys like get that claim of orthocentric by backtracking or like it's from here only obvious?
Yeah,
It's
no,
it's
that's
not
clear.
direct. I think we can show it though.
Yeah. Okay. So right now we have like this is basically a homotheity, like it's homotheity of ABC and like that lie X, Y, Z lie on that.
Like we have 9 point circle of basically like
But we
everything.
don't wait, where we have 9 point circle? Like
We have
AB
9 point circle of
ABC is your 9 point circle for ZTY.
yeah, ABC is the 9 point circle.
Wait, how do we know it's
So wait,
orthocentric? How is like
no,
X
we don't know
orthocentric?
we don't know
like
that.
like yeah, we can have like such a thing, right? Like X is some random point and then like
Yes, like the
ABC are
further.
just
Yes,
Yeah.
now because the midpoints are collinear with all those midpoints, the midpoints of these three lie on the 9 point circle, which means that say taking commodity sense the 9 points are equal to the circumcircle, which implies it's a percentage.
What?
wait, you had to like repeat whole argument because we couldn't understand. But
So we
yeah.
also know that the midpoints of YZ, ZT and YT are there. So therefore, the midpoints of XZ and XT lie on the 9 point circle of YZ and
Oh,
YZT.
I get it. Okay, so because midpoint of like this triangle also. Yeah, I get it. Okay. Yeah, you're right. So the midpoint of this triangle, I also lie on the circumcircle because it's basically same. Like there's nothing special about X. Yeah, I forget about that. And this imply like because of midpoint, 9 point circle become middle triangle. So this has to be the same thing. And now, can you prove X is a? It should be obvious, right?
Yes, by commodity, sending 9 point circle to circumcircle.
Yes. Uh,
Yeah.
Yeah, so like if like circumcircle is something like wait, isn't that just basically the thing? Yeah. So wait, so radical axis is same? No, right?
Then don't you get like if M denotes the midpoint of ZT, N denotes the midpoint of ZY, and say K denote the midpoint of YT, then their Simpson lines would be the radical axis of omega 2, omega 3, and omega 4. Like, don't you have that?
Like for
Yes.
Like for example,
radical
if you let N be the midpoint of ZY, and then you drop and then you make it Simpson line, then won't it be the radical axis for omega 3 and omega 2? Like, yeah.
yes, yeah.
And
Uh,
similarly, you can do the same for M and K.
uh, yeah, and I think I get what you mean. So like this is a radical no, so like this lie on 9 point circle, and because like from when you take a homothety from X sending this nine circle to this circle, the Z lie on that circle too. So X has to be orthocenter,
Right.
right? Yeah, and this the centroid in 9 point circle. Like I think now it should be obvious. So like call this O and X is the orthocenter. So like what's the ratio thingy? So like if you have something like here G dash. Wait, I just want to note like how can we have uh, okay, I get it. So what happens is like so like from this point, like okay, now the problem becomes kind of done. So what is like we have Simpson line is the radical axis, right? And
Yes.
reflection of Simpson line on the orthocenter. So this should bisect the thing, right? And now we kind of have like all those things should like pass through radical center, right? And wait,
Right.
those
They
should
will
not
be
be those.
like the radical axis of omega 2, omega 3, and omega 4 would be concurrent, at a point. Call that
Yeah,
L say.
L. Yeah, okay, sure.
And
I'm just trying to
You're
visualize
calculating
the
at R, the L or whatever, yeah. At the
yeah,
radical center.
but oh wait, my bad. Okay. Yeah, they should concur here somewhere. Okay, I should just change the diagram coloring. All this green point. Yeah, so suppose this is L, this is the radical axis, then there will be another radical axis from Simpson lines of these 3 points concur at L, and you want to show it get bisected by like G in like 2:1 ratio. I just want can we figure out what's G in the triangle YZT?
okay, like I have one more idea that I don't know if this is true or not, but if you let H be the orthocenter of ABC, then I think that HL and like HL and LP would be equal, where P is the circumcenter of ZTY.
Wait, give me a second. So if H is the orthocenter and then I
And you
should
let P
also
be the circumcenter of YZT, the big one.
okay.
And
Uh,
I claim that HL should be equal to LP.
let's call it T actually. And
Okay, whatever, just
oh
like
no, not T, not P. Okay, let's call it P. But
no,
what was
you can
this?
just call it O. I mean, it doesn't really matter, right?
Yeah, yeah. I'm just say what are the equal things?
Like, I'm just saying that HO is equal to HL.
Yeah.
I don't know why this is true.
Hmm. That might be true. I'm just like okay, let O be here somewhere. We actually don't know O lie on XL or not. Like G is the centroid, not needed to be centroid of the original thing. Okay, so G is the center of N, Y, Z dash, and we have like from orthocenter, we take like the middle lines which concurrent at here. So wait, this should be now obvious. I can't
Wait, why
see
is
like
G center of N? Why did I said that?
so it's like which better way to say is like T Z Y. Then we have like N Y dash Z dash, and then like this the like median triangle, right? So like G is like centroid, and then G also centroid of this because these are also
Wait, no,
midpoint of
G is centroid of ABC, no?
oh my god, I'm so good. Okay, yeah, C is centroid ABC. My bad, my bad. Yeah, okay. C not needed to be centroid.
Wait, consider a homothety at H with ratio 1:2. So then
Uh,
you drew the green radical axis, right?
yeah.
So then that radical axis will go to the perpendicular bisector of XY. Because
Wait,
like Simpson line
homothety
bisecting.
homothety sending what? Oh, okay, yeah, sure.
Huh. So then the radical center uh, of some things.
Okay, like so by like you can just send you can just make a homothety to send all the Simpson lines to pass through the circumcenter. Like centered at H, you make all the Simpson lines pass through the circumcenter. I think that makes HL equals to LO.
Okay, so
Uh,
if you take this homothety, if you consider okay, so let's call the radical axis, the green radical axis you drew as LXY.
okay,
And we can name the others similarly. So you consider
yeah.
a homothety at LYZ, LZT, and LT, taking LYZ, LZT, and LTY to the perpendicular bisectors.
Wait, perpendicular bisector of what?
Of
Now,
YZ, ZT, and TY.
no, wait, aren't they already like so this Simpson line should bisect XY, right?
No, the
No, it
Simpson line,
bisects
it
PH.
Oh
bisects
no,
HP.
Sorry, what? HP, yeah, sorry, that's right.
It bisects HP.
Yeah, okay, it's bisect HP. And now
So,
like you're
so
taking
after
that
the
homothency.
so after the homothency, it will perpendicularly bisect XY.
Uh, okay, yes, because you take a homothency sending this to orthocenter of XYZ, XYT, right? And then this will become 90, and it's this thing.
What?
Okay. No, so you take a homothency sending like this
At
Z
H?
circle to
You take a
well
homothency
wait.
at H, taking homothency at H with ratio 1/2, right? Sorry, with ratio 2.
Okay.
So
Okay, yeah.
LX
Okay.
LXY will go
Yeah.
to perpendicular bisector of XY.
Yes, yes. Okay. That's I get it now. Fine.
So then
And
I think we'll
yeah.
just consider LYZ, LZT, and LTY.
Yeah, this line, green lines, right?
Um, Sorry, what?
The green lines, they are perpendicular bisector of X, Y, X, Z, X, T, which are the
Yes.
homothency of H. Yeah.
Yeah. And similarly, we can consider LYZ, LZT, and LTY.
Okay.
So the
Yes.
radical center of omega 2, omega 3, omega 4 will go to the circumcenter of YZT.
Oh, I get it. Okay. Okay, actually, yeah, okay. Let me just find a better way to. Okay. There's a better way to phrase it. I don't want to write. Okay. Does everyone just focus on my color line? Okay. I'm just explaining. I get your idea. That's like okay. First, we have n is the midpoint of zy, right? Because of the previous thing, this and it lie on ABC. Now the Simpson line of n is a radical axis. So this Simpson line. This is radical axis for circle center at z and y. So that imply it's a perpendicular to zy. So this radical axis is perpendicular to zy. Now, because this lie on circumcircle of ABC and let's H be orthocenter of ABC, then we know this like Simpson line get bisected by HN. And thus like once you take a homothency from H, sending this like LZY to like a homothency of ratio 2, then it will go to like the line perpendicular to ZY from N. But notice like that's basically like the line perpendicular to like ZY from the midpoint, right? So that imply by like it should go to like center, like circumcircle of ZYT. And similarly for all lines. So the radical axis of like this other circles, right? Like Z Y T is like some L, okay? And the point is that when you're taking homothency of this ratio 2, all of them goes to this like line like perpendicular to side lines from midpoint, which imply it should goes to O. So that imply like L is the midpoint of HO, and yes, now it should just finish because it is the midpoint of HO.
The
And now we
9 point
want
center of ABC, right?
uh wait, what?
Who is the circumcenter of
Oh,
ABC and
no, O is the circumcircle of YZT.
oh, right. Sorry.
Yeah.
So then it becomes
Yes. Okay, now we need a G. So we need circumcircle of this. Oh wait, it's a 9-point circle. There should be a way.
yes. So wait,
Oh yeah, okay, I find it. Okay. This diagram. Sorry guys. Diagram will be horrible, but it's better with color. See, this x is the orthocenter of like just consider z y t. X is the orthocenter of z y t, and let call o dash be a circumcircle of ABC. Then we know h g o dash are collinear Euler line in ratio 2:1. We also know o dash x o are collinear because of Euler line of z y t, because this is a orthocenter sorry, 9-point circle, 9-point center, and circumcenter. So this is 1:1. And now, so what we have in the end, beautifully, is like O dash O
Oh, G is
X.
centroid of that. Okay, yeah. I think we're
Yes,
going to G
L.
centroid of XH.
This is 2:1, and this
Oh
is
yeah,
two
and
is
it's
to
centroid.
one,
Yeah, yeah, done. Wait, what?
and this
HLO
is
is
1:1.
HLO is one is to
Okay.
one. HLO is 1:1.
Oh yeah, okay, my bad. Yeah.
So that means
And
it's 2:1. Yeah.
G becomes a centroid of XOX. Yeah.
But wait, why is it centroid of ABC? Oh yeah, HGO. Fine.
Yeah, because like this dividing half and this
Yeah, yeah,
dividing
correct,
half,
correct. Done, done.
and you're done. Yes, this was the problem. Now tell me, wasn't this beautiful? Like the weird chord condition just spam the beauty. Yeah, sorry about diagram, but like the ideal way is to draw another diagram after like getting this simplification of like the Simpson line, right? We have midpoint of things, so now we just take midpoints. But like, who follow the ideal way? Also, like once after getting the Simpson thing and like 9-point circle, this problem reduced to like general problem, right? Like basically ABC are like points on the this thing, like any point on 9-point circle, and then we have G and H, and then we can prove like this thing follows. So like it's become general problem, but like it was just left to observation of P. And I'm not saying it's easy to come up with. Like when I was solving, I was not solving it alone. I was solving with Raghav, and he come up with the idea that time. And it's a quite hard idea to come, to be honest. But yeah, the point is like you want to like have this two length ratio same to work with. And I think we would have like we were close. Like I called for this midpoint of this thing, right? So the point is like we have equal chords, so you only focus on BC, and once you try to focus on BC, you try to look at like what can be like good things about like good points on this BC, what can be, and the radical axis. And once we have this line radical axis, then we have Simpson line, and then we introduce orthocenter because we have Simpson line. Then we do homotheties, which give us circumcenter, and which reduce to the this. And we're done. Was it good? It was nice problem. Let me just pull up the source. This time it's not China TST
Is this
because
from a
you
Russian
guys.
Olympiad or some Russian contest?
How can you do that?
No, there
How
are
can
like
you?
too many
Sharigan.
circles over here. It
It
looks
is
very Russian.
it is Sharigan.
Wait,
It is
yeah,
fine.
it's a Shari.
Why do you know that?
Shari.
What
I
problem
also
is that
don't.
though?
Wait, why, Resh, you know the problem or?
No, I've seen the problem.
Oh, okay, okay. 1.8. Final shall begin. I just don't want to misspell it here. A beautiful problem. And yeah, I like some beautiful geos are like the Russian make beautiful geos. That's just fact, right? I can't deny that.
In Geo is very nice.
Yeah.
Also 10.8.
Okay, yeah, my bad. I also wondered 10.8. So it has to be what? Oh, last problem. Nice. Okay. Yes, I hope you guys done a lot of things. I intend to cover this problem, which was another China TST, so I could have make a high trick. But I intended to cover this GA. But it's nice that I didn't spoil you the problem. So just do this problem. Do this problem also. It's actually fairly easy, and it's a G6. Yeah, fine then. Uh, does anyone have doubt about here something? Okay, fine. Uh, Bye bye you.